In this example D6, we wanted to look at a frame that was asymmetric. The columns were not at the same height. We also had an asymmetrically applied gravity load, and we had originally guessed that the frame would deflect towards the stiff end, stiffest part being the column there, but when we worked through in our guess that moment diagram, it didn't really make a lot of sense. When we allowed the structure to sway to the left, we found a moment diagram that was far more consistent, not with this showing deflected shape, but one that made more sense overall and resolved some potential conflicts or hypocrisy of the, not hypocrisy, but conflicts in the moment diagram that would go with this deflected shape. Now, in the working of this, we went ahead and left in the slope deflection approach the sway drawn to the right. It made some of the math a little bit more convenient. We worked all the way through the work, and we found out the deflected shape indeed was such that we had sway going to the left, and that was consistent with our modified guess. That's what would happen, that we had clockwise rotation at the upper left, counterclockwise rotation at the upper right, and the moment diagram that ended up resulting was that the column on the left had an S curve, the column on the right did not. It was in single curvature, and that we would have moments that were of, well, we actually thought we'd get a bigger effect over here to the right than what we ended up doing, than what really actually happened. And so we're going to have to be a little bit careful about generalizing our understanding of the results, because there were a couple of really bizarre kinds of effects. We have a fixed end, for instance, at D, and yet we ended up with a zero moment, which is a pure happenstance of the situation. And because of that alone, we have to be very careful about trying to take too much away from the relative values the moment. This is one of those pathological kinds of situations that you don't expect to have happen. But it is kind of interesting that this short stiff column ended up having overall less stress really than the rest of the system, which is unusual. That's not typical in indeterminate systems. So again, we got to be careful how we interpret it, what we take away from the situation. We know to be careful just based on we've got this pathological result of a zero moment down at that fixed end. Now, one thing that is a lot more consistent, though, is that in a generalized kind of thing, is that the structure actually is going to sway away from the stiff side and towards the more flexible side, which actually does kind of make sense. Initially, you might want to think that this load is going to want to move over on top of this stiff element. That's that short piece that's closest to it. It just doesn't work that way. You have more flexibility over here, and that allows it ultimately to move and flex towards the left, away from the stiff end. And you can also demonstrate this by taking column AB, making it the same height as the other one, CD, and seeing what happens. Now, if you move it up and make the whole thing stiffer as a result, you will still get this left-hand drift. It'll be a lot smaller as a result, but it will go slightly to the left. Even when you include axial deformations of the members, you still get a little bit of leftward drift, because again, the load here now, the structure is symmetric, but the load is not, and so the effect is going to be to move things over towards the more, relatively in a sense, the more flexible side of things. Right? Flexible is kind of an amorphous term at that stage. It's going to go away from where it's closest to, is what that all ultimately means. Right? So that's probably the only general rule of thumb that you want to take out of this example, is as you're guessing what's going to happen and you got these asymmetric loads and a relatively simple load, in this case only one, it's going to move away from that. The shorter, stiffer side is going to move towards the more flexible or far side of things.